Hello, my name is John Maddog Hall, and I am the board chair of the Linux Professional Institute and the president of Linux International. My talk today is called Latinoware, the Footnote. Where do you go now? For those of you who don't know me, who is Maddog? I've been in the computing industry for 50 years. I've been coming to Latinoware from almost the first version. I love Latinoware. It's a great conference and put on by very nice people. You're at the end of Latinoware, the virtual, but you can't go home because you probably are home. Or maybe you're at work. So I'm going to talk about some truths of free software and open source and hardware and software in general that you may have learned this week at Latinoware. First of all, you don't really buy hardware or software. What you buy are solutions. You have a problem and you want to solve it, and it just so happens that a computer and software is a way of doing that. You do not own the software that you buy. You're really only renting it, and if you don't believe me, read the license. Your software warranty is also useless. The very best thing that can happen is that you might get a new copy of the software, assuming it doesn't set your computer on fire. And neither free and open source software or closed source is inherently more secure than the other. This is argued back and forth. But the real issue here is whether or not you can fix the problem that you have or you can't. Because if you can't fix that problem, if you can't change that software, if you can't apply the software the way that you want to do that, then you're a victim of what I call software slavery. And you have no control over your software, and it could be you have no control over your business. Now, many of you are beginners, and you're saying, Maddog, I've been here in this virtual conference for a couple days, and I've learned a lot, and you've helped me, and all that type of stuff. How do I start? Well, I recommend that you have a plan. How are you going to go from where you are today, perhaps a user of closed source software, to where you want to go? And part of that plan is, what programs do you currently use? What programs do you anticipate using in the future? Are those programs going to work on your current and future operating systems that you have? Could they possibly run in a virtual machine on the operating system that you do have? There's lots of things that you really need to get clear before you start going forward, so you know where you're going. Does your target hardware, the hardware you want to have in the future, is that going to be supported by the operating system you use now? Or are you going to have to switch to a completely different operating system to get the functionality of that hardware? So you need to start searching the information on the internet. Be careful when you do that of when the articles are written, because a lot of times things change. And an article that was written 20 years ago may be not as applicable as it is today. Search for strings like best Linux distribution for beginners. And of course, if you speak Portuguese as your native language, you would do this in Portuguese or Spanish, in Spanish language, to make it easier for you to read and understand. But if you do speak English, or at least read English, don't be afraid to look for the English text also. And be aware that some of these distributions of Linux and free software, and that includes BSD and the other types of Unix systems, they may be more interested or oriented towards server systems or embedded systems and less than desktops. So as you start to look for the software, look for the best that suits your needs. And there's lots of different articles on the net that talk about the things like the 20 best open source programs for this, for doing this, for, you know, visual stuff, for its music or whatever. And you start to put together your software map of what you want to do. And maybe you say, well, I'm tired of Internet Explorer. I got tired of Internet Explorer the first 20 seconds. So you could use Firefox or Chromium or some other open source package. You might think about using LibreOffice to do your day-to-day work instead of Microsoft Office. But there's lots of other Office packages too that you might try. GIMP is a raster scan, a manipulation language for digital pictures. You can use that instead of Photoshop. You can use Inkscape instead of Adobe Illustrator for vector graphics and doing drawings and things like that. And you can find those 20 best source code programs for whatever you want to do on the web. And then you can pull them down. Now, another way of finding out information and stuff is by talking to other people. And if you're in school, whether it be a high school, grade school, or university, find out if there's a computer club in your school. And if not, why not start one? You don't have to be the best technical person to start a computer club. You can find plenty of technical people around. But what you need is somebody who can find a room, set a time, ask for topics, things like that. And so you have to be a good organizer. And from that, you can pull in people to give talks about things that you want to learn about, and other people want to learn about it too. And then you all learn. Look around to see if there's some local user groups, which we call LUGs, Linux user groups around. They could be either physical, meeting someplace once a month, maybe meetups or something like that, or they could be virtual, online. Maybe it's just a mailing list of people who ask questions and answer questions. And maybe there's people in your extended family who use GNU Linux and you just don't know it. They never talked about it, they never brought it up, but they're interested in computers and they might be interested in Linux, and they could also help you. So the next step would be to find a particular distribution that you want and install it on your computer. And of course, you search the internet looking for people's recommendations and things like that. But now you've got the distribution, you've figured out which one you want to use, and how do you install it on your computer? Well, some people say, I'll just go cold turkey. I'll just wipe out the operating system I have and install this new one, and that's it. Some people say, well, I'm going to try a live distribution, one that runs off of a DVD or runs off of a flash drive, and I'm going to boot that on my computer, and I'm going to test that out, first of all, to see if it recognizes all of my hardware. And, and then go ahead and use it and try it out a little bit. After that, you might try a dual boot. Now, maybe your computer system has 2 or more disks in it. You can install the GNU Linux distribution on a separate disk. Or maybe you only have one disk, in which case you partition your disk so, your current operating system is on one side of the disk and GNU Linux could be on the other. And Linux supports that. We allow that to happen, and you can do that relatively easily. You could install it on one part of one disk. That's partitioning, which I just talked. Or you could put it on a USB or a hard drive, either a hard drive or an SSD, USB, external drive, or a flash drive, and then boot it by plugging that in and booting that particular device. So there's many different ways you can come up with this dual boot situation so you can use your original operating system or use Linux. Now you could also do a VM, a virtual machine, on your current operating system, and then you can install a GNU Linux into that virtual machine. Later on, you might find out that it's actually faster to run Windows on the virtual machine that is itself running on a native GNU Linux. And there's technical reasons for why that happens. And another thing you could do is just find an older computer that maybe somebody's cast off. They've gotten a new computer. They don't know what to do with their old one. Say, hey, could I have that older computer? I want to put Linux on it. And you could put it on that. Now, all of the major distributions, and you may have heard their names here at Latinoware or elsewhere, distributions like Debian or Ubuntu or Mint or Red Hat, all these different major distributions that have huge followings would be a good place to start. And usually at the website for that distribution, they have good beginner's documentation, how to install it, how to use it, how to migrate things to it, things like that. They're also, because it's a major distribution, more likely to have other users of that distribution nearby. And they're also better to have, more likely to have better end user support. Not guaranteed, but more likely. But do me a favor, and do not put GNU Linux on a really old piece of hardware that like only has like a half a megabyte of RAM, and it has a really slow clock speed, and it has an old graphical processing unit that only does 1024 by 768 resolution, and it only has USB 1, and it only has 802.11b Wi-Fi. And then you could probably get Linux running on that, but then you come back, oh, Linux is so slow. It's terrible. Yeah. Put it on a more modern piece of hardware, a little bit faster, and see what it does, right? I mean, you're not going to squeeze blood out of a turnip. So ask questions of other user groups before you don't ask questions of other user groups before you do your own searching, because number one, you want to be able to understand what they're saying. You want to be able to present your question in the best possible light, and you don't want to waste their time. But if you do have a good question and you have done research and you have tried to puzzle it out yourself, then most of these user groups are willing to help you. Now, that's if you're just a general user, you just want to use Linux in your day-to-day work and things like that, you can do that. But what if you want to be a professional? What if you'd like to earn a living with free and open source software? Are you interested in being a systems administrator? Because today there's a huge number of companies that use Linux in their company in one place or another, and they need good systems administrators. And to be truthful, systems administrators to know Linux and know Windows and perhaps know Apple, a wide variety of different things. But you could go in just knowing Linux and they probably would be happy to have you. Maybe you want to be a programmer. Maybe you want to be a systems engineer, actually designing systems for other people. Or maybe you want to be what we call a solutions provider. Remember, nobody ever buys a computer, they buy a solution. So you create the solution that other people want to buy. So let's take a look at a systems administrator and what they need to know. Now, you may say, I don't have any idea what a GNU Linux systems administrator needs to know, and I don't know where to start. And fortunately, the Linux Professional Institute can help you with that. If you go to their website, lpi.org, you can find different exams for a beginning systems administrator, a network systems administrator, a more advanced systems administrator. And when you look at each one of those categories, you find out that there are objectives of each category. So, for example, a beginning systems administrator has to know how to install the system on a piece of hardware. They need to know how to add a user to that. They need to know how to set the time and the date. They need to know all these things. And the website lists the things you need to know. So you go in and you learn them any way you want to, by reading a book, by practicing, by searching the web for ideas. And once you feel you know how to do all of those objectives, then you take the test and you get certified. Of course, you have to practice this. You can't just read about this and hope to pass the test. So you have to practice it. You can set up some old servers or old laptops in environments in your house or in your place of work And you can test out your ideas on those. If you're at a university, you can volunteer to help take care of some of the systems at the university. Or maybe you know a nonprofit. Maybe there's a church nearby and they'd love to set up a Linux website or something like that. You can do that for them. And once you've done that, you get a letter of recommendation from that person. You put that in a little folder and you keep that so that you can show people later on what you did and how well you did it. Finally, you might think about teaching other people how to do this, because there's really no better way of learning something than having to teach it to somebody else. All the things you skip over because you say, oh, I'll never need that. I'll never need it. You're teaching it to somebody. Then all of a sudden it's, oh, that's working. So teaching something to somebody else cements that knowledge in you. And as you're studying all these things for systems administration, don't forget about learning security. Security these days is very, very important, and we need to have people who can keep our systems secure and know how to fight off the bad people. So that's systems administration. What happens with programming? So you say, well, what's the first language I should learn? In almost any Unix system or Linux system or BSD system, or even in Apple systems, you have something called the shell. It's a command interpreter. It's the first thing you talk to on the command line. It's always there, and it's very useful. It's very powerful. Learning how to put together the commands of Linux and Unix and to do the work to get the solution that you want is a very powerful thing. These programs are very efficient. They work very well. And learning the shell script is very good. And there's books on how to do this, even books written in Portuguese and Spanish. So you can learn this relatively easily. A second language might be Python. It's very well known. It's very well wide. It is an open source language. And if you learned Python as a programming language, that would be the next step to that. The third step is kind of controversial, but I believe that this is what should happen. You should learn something about assembly or machine language, because this is the ones and zeros that the computer uses to do its work. And in learning this, you also learn things about machine architecture. How does the machine really work? How does it do the things you want it to do? And by knowing this, you can understand some of the other languages and things that happen. After that, you might learn any one of a number of different languages, Haskell, C, C++, but I typically point to C because it's the language that the Linux kernel itself is written in. The part of the operating system that controls everything is written mostly, 99.99%, in C. And finally, there's many, many languages which are good for many, many things. And you should learn some of them as different languages to do different things in computer science. But computer science, of course, is more than just computer languages. There's a concept of programming style. How do you put your program together so that other people can look at it and see what it does? That your code fits in with other people's code. And this is important. You need to learn algorithms. How does a sort work? How does a search work? What's the most efficient method of sorting and searching? And there are books and magazine articles and articles in the web for doing this. How do you take your very large program and break it down into smaller parts so that each one of the different computers or the different parts of the computer can be working on it at the same time in parallel? What about graphics? What's the best way of coding graphics? And these days, taking the graphical engine and using it to speed up other types of programs with parallelism. And newer on the marketplace are these things called field programmable gate arrays, FPGAs, or ASICs, which are like an FPGA except fixed at manufacturing time. These can speed up certain types of programs hundreds of times over the fastest CPU that we have today. And they use less power, less electricity, so they're good too. So you can learn about these different things and hundreds of pieces more. Do not get into computer science if you don't enjoy learning, because you will be learning for the rest of your life. I have been programming for 50 years. There's not been a single day in those 50 years, not a single day, that I have not learned something new. I have never been bored, because to me, boredom is the worst possible thing. There's also some newer topics coming out that are kind of exciting. Data mining, looking at huge amounts of data and predicting where things are going to go. Weather, as an example, earthquakes, traffic, hard problems that we need to solve. And data mining is one of those ways of doing that. Artificial intelligence, I actually hate the term artificial intelligence. I would like it to be inorganic intelligence, but that's me. Big thing in the world today, and it's going to be a big thing in the world tomorrow. The Internet of Things, controlling lots and lots and lots of devices around your house or around your work, gathering the data from all of them, massaging the data, processing the data, and then sending it back to the people that need it. Maybe you want to go to a university and actually study computer science or computer engineering. Computer science typically is the operating system, the compilers, and the upper level parts. And computer engineering is the compilers, the operating system, and the lower level parts, the hardware and the things called, BIOS and device drivers. That's how they're mostly split up, but not all the time. And, you try to go to university stuff, or maybe university isn't meant for you. Maybe you don't like the idea of going to university. So there are 3 articles on the web put out by the IEEE ACM. These are big computing organizations that have been doing this for hundreds, or at least 100 years. The IEEE has been around, the ACM something somewhat less. But they've gotten together and formed these curriculum that list all the courses that people should take in the order they should be taking them in, what each course should cover. And you can pull these reports down off the web, and you can look at them, and you can study them, and you can read the materials, and you can figure out that these are the things I need to know to be a computer science person, to be a computer engineer. They don't give you the tests. The tests are not there. But you can handle the test different ways, either through certification or through doing the work and creating what we call a portfolio. So go to these. They're very important. And every so often, every few years, they update these curriculum. And these curriculum are used by over 340 universities around the world. You should be insisting as students that your universities teach using free and open source software and hardware and culture. Because closed source only teaches you one time. You learn how to use that software to solve a problem, and that's wonderful. But it doesn't show you how the software works to solve that problem. And it doesn't allow you to make the software better to solve that problem. And that's why open source and free software teaches you 3 times. It also teaches you how to create free and open source software in real life projects. When I was learning computer science, we created these fake compilers for fake languages, fake emulated operating systems that nobody used. And today, you can study with free software operating systems that are used around the world in major projects and you can see how the operating system works. You can change the operating system to be better. You can participate in those projects. And it's just not just about the software people or the computer people. You can go out to different disciplines at your university and bring them in and help you to set up a project or a business that people can contribute to. You can be the people who create the next breakthrough. And I will tell you that when I was in undergraduate theory, I'd say, I'll never use this. I'll never use this course. This is stupid. Why are they making me do this? But in the 50 years since I graduated, I have used every single course that I ever took in my undergraduate curriculum. So one of the things you can do is to join already existing projects. Things like audio players and CD rippers and databases. If that is your interest, if you like games, if that's your interest, you can join these projects and work on them. You can study their email lists, and you can study their bug tracking system, and you can find the bugs that they want to fix, but they don't have time to do it. So you fix some of the bugs, you match your programming style with theirs, they accept your bugs, your bug fixes. And after a while, they say, hey, you're doing pretty good at this. How would you like to write some low-level functionality for us? And so, yeah, do that. Low priority functionality, not a big time pressure for it. You do it, you put it in. After a while, they say, you're really good at this. How would you like to join our core team? Be the people who, find out what direction this project is going to be going in. And after you do that for a while, they say, would you like to get a job? You could work for us. We're funded by this computer company over here. Or you can say to them, I'd like to find a job out in some company. Could you give me a letter of recommendation? And you take that letter of recommendation from them and you put it in your folder, and you gather up pieces of your code and the email discussions from the email list that you did, and you take it to your prospective boss. And you say, this is why you should be hiring me. Not because of some stupid resume I filled out and handed off to your HR department. This is why you should be hiring me. And it's because I did this in university 50 years ago that I got my first job, which has influenced my entire life since then. Now, you could also consider building solutions. We've talked about systems administration. We've talked about programming. We're going to talk about building solutions. You could build a multimedia center, and we'll talk about each one of these in turn. Or you could build a point of sale and ERP system. Ever go to McDonald's? That cash register they're using is a point of sale system. And behind that, the cash register feeds into this enterprise system for keeping track of things like inventory, customers, things like that, calendars, all sorts of lists. Very powerful. You could have a secure home server. Why pay for a VPN system? Why pay for reverse DNS? Why pay for all these things when you could actually have that in your house, and you could store your most precious of things on that server so that it won't be seen on Google, it won't be seen on Amazon. And we can show you how to do that. You can set up a portable web publishing system. All sorts of things you can build out of the over 400,000 applications which reside in open source repositories programmed by 26 million people. So, as an example, consider building a multimedia center. You want to have surround sound in your house? Just using regular old speakers, nothing special? Would you like to create Internet of Things to control your heat, your light, and stuff like that? Would you like to have a security system that if somebody comes through your front door, it snaps a picture of them and sends it to you on the cell phone? Would you like to be able to do video meetings and things like that? You can do all of that through software that's free and open source. There's a package called Kodi, which can be put on top of a single board computer, like a Raspberry Pi or a Labrador from Caninas Lucas. And you add an LCD panel, a keyboard, a mouse, an amplification system, some speakers, a webcam, and, if you want to, a USB tuner for over-the-air TV stations. You can put all these things together. This little single board computer can replace the wireless router you have in your house, because the little single board computer plugs into your modem, either cable modem or DSL modem, and then can distribute the Wi-Fi to the rest of the devices in your house. So this is a great system. It allows people to have a really nice, multi-channel computer. Or you can start small with just 2 speakers and a subwoofer, as I show in the picture. But this could also be the first connection to the internet for people that don't otherwise have a computer in their house. It only draws about 20 watts while it's running. That includes the LCD panel. The speakers, of course, draw a little bit more. And you could put this together and then sell this and install this and update this and maintain this for all the people in your neighborhood, so that you could actually get some money from selling these systems and putting it together and maintaining them for them. Here is the point of sale and ERP system I was talking about. Again, it's just a single board computer, whether it's a Raspberry Pi or whether it's a Labrador. And you put together a USB scanner, scale, printer, cash drawer, an optional 2.5-inch SATA disk or SSD, and an LCD panel with a touchscreen to be able to have a point of sale and ERP system. Now, normally these sell for tens of thousands of dollars, and you can make them much, much cheaper. This software is supported by like 9 different companies in Brazil alone, and many more throughout the rest of Latin America. And it's an open source solution, so as you gain in experience and expertise, you can change it to meet the needs of your particular customer. And of course, they would pay you to do this too. Even if you used Odoo as it came out of the box, you can install it, support it, and train the storekeeper in how to set it up and use it. And all of this, of course, you would be paid money to do. Consider building a secure home server. This uses a piece of software called FreedomBox. It has all these different things it can do, but it's made to be relatively simple to set up, and it's updated periodically. It runs in a series of single board computers. You can either use a micro SD card or a USB hard disk or SSD to hold your data. And this gives you many of the different types of server services that you would normally pay for free. Debian 10 has all the software built into it, so you could just put Debian 10 on this and then just energize the software. And again, you could put these together, sell them, install them, support, and train people in your neighborhood on how to do it. So you can be your own boss. Instead of working for a company where you work really hard and the boss of the board of directors walks away with a lot of the money, you could be your own boss. And you could put all the money you earn into your own pocket, minus taxes, of course, but instead of sharing it with a bunch of people that don't do any work. We are starting a project called Project Cauã. I've been working on this project for 12 years, and we are going to be starting Project Cauã in full force. teaching people how to create their own business, what you can do in a day, and then running your business like a businessman. We hope to start this around the beginning of the year. Please keep track on local media for it. You should be insisting that your government uses free and open source software, hardware, and culture. You should be saying to your federal, state, and local governments, you should be creating local jobs to take software off the internet, free software off the internet, and use that instead of paying hundreds of thousands of dollars and reais and pesos to the United States, to Europe, to China, all these places, because if you do that, then you can take the fees that they would pay for those licenses and pay that to local programmers to create local housing, local food, and local taxes. The money keeps circulating inside of your country. It also increases local expertise in how to do relatively, impressive software and hardware. And this allows other companies to come to your country to set up their research and manufacturing. Because if they do not know, if they do not see the trained people in your area, they will not come. And likewise, even though a lot of students are trained and graduated from universities in Latin America, the best of them always want to go to the United States. They always want to go to Europe. They always want to go to China. And they say, I want to go there because that's where the interesting work is done. Silicon Valley, Redmond, Washington. Why can't the interesting work be done where you live, in your country? And these are the things that you need to be asking your governments. You have better software at lower money, which means lower taxes and more services. And you have a greater transparency of the software across governments. How do you know that the United States is not putting a trapdoor in the software that your government is using? You don't. And I know that there are these transparency centers where, large companies say, oh, come and look at our source code. You can look at our source code. You can see there's no trapdoors. But they never tell you how you know that that source code is what made the objects which you're using. They don't have to tell you that. So all non-secret software made by the government, purchased by the government, used by the government, should be open and available for anybody to see it, to figure out, and anybody to use it because you paid for it once with your taxes. Why should you have to pay for it again? So up until now, I've been talking to students and educators, and now I'm going to talk to business and government. I recommend that you use free and open source software and hardware and culture for all new projects. This will help you bring the project in on time and under budget, not having to pay huge licenses to companies who are just going to give you a database when you could use a free and open source database. Create the business plan before starting the project. See how much it would cost if you use free software versus proprietary closed source. Look to use free software if you're going to update the hardware that your current projects are using. This might be the time to switch your system. Look at if you're about to renew your license, because that's the time that you might put that license renewal money into creating a better system with free software. All the application software that you write above the proprietary systems you use now, write that software to be portable. So in the future, you go to a new system, you can just move your software over. Everybody listening to this should become a proponent for free and open source software, hardware, and culture. Talk to your family, talk to your teachers, talk to your management, talk to your staff, and be ready to come to them with complete factual reasons why you should be using this. You can create the solution that you want to use. And in doing that, you can control your future. Thank you very much for listening. My name is John Maddog Hall, and I am the Executive Director of Linux International and the Board Chair of the Linux Professional Institute.
Hey, Maddog, good to see you again. Can you hear me? You're mute. Your microphone is mute. Still can't
There we
hear
go.
you?
There we go.
Oh, good, perfect. I believe, let me change to Portuguese a little bit. Juarez, é tu que está aqui na sala, né? Se tu puder colocar só um minutinho, rapidinho, aí o Flávio, tá? Aí depois pode deixar só eu e o Maddog de novo, aí se eu precisar de ajuda eu chamo o Flávio de novo. Maddog, here's Flávio. When you sent me your presentation, I was already working on Latinoware, so I translated half of that into Portuguese, and all of the other subtitles that who did it was Flávio. So I wanted to bring him in here just to thank him for doing that for us.
Yes, thank you very much.
Eu tava falando, pode colocar o Flávio no backstage de novo. Eu estava contando pro Maddog que eu recebi a apresentação dele para fazer a legendagem, só que o Latinoware já tinha começado, estava envolvido com o Latinoware, então o Flávio, que é voluntário do LPI, nos ajudou com a tradução e por isso que eu queria fazer esse agradecimento especial para ele. Well, let me get some questions in here for you. Well, first of all, when you mentioned that all governments should use free and open source software, and we should insist that our governments should use free and open source software. Yesterday, we had a presentation from the University of Costa Rica, and they are a public-owned university, and pretty much everything that they use in there is free and open source software, in a migration that they started 10 years, more than 10 years ago. The question that I have to you is, as we have already several examples, especially in public-owned universities, why don't governments just copy and paste these examples in all other universities? Let me translate into Portuguese and then you can reply to that. O Maddog estava contando na palestra dele que todos os governos, e a gente deveria insistir que os governos utilizassem softwares livres e de código aberto, porque afinal esses softwares são pagos com os nossos impostos. E ontem a gente teve uma palestra do pessoal da Universidade da Costa Rica, uma universidade pública, que há mais de 10 anos já migrou, um processo que começou há mais de 10 anos, mas migrou praticamente tudo que eles têm dentro da universidade para software livre, desde servidores, sistemas administrativos, até os desktops de todos os docentes. A minha pergunta para o Maddog foi, existem casos já de universidades que fizeram isso. Por que é tão difícil isso ser replicado? Por que simplesmente não se faz copy-paste desse processo aí de uma universidade para outra, especialmente universidades públicas, cujos softwares são pagos com os dinheiros dos contribuintes? Up to you, Maddog.
Well, in my talk, I did say, talking to, I think it was business owners, that when you create a new project, you should be considering using free and open source software. And the reason for that is that in the past, people would say, oh, I'm going to switch over from... Oh, yeah, I should stop.
Ele falou assim que o que ele tem insistido, e especialmente quando ele fala com pessoas de negócios, é que se for começar um novo projeto, esse novo projeto deve ser começado com software livre de código aberto. Ok.
So in the past, people say, I'm going to switch everything at one time. And that requires a lot of training and a lot of disruption. And then people get finished and they say, so what? What did I get out of it?
No passado, as pessoas insistiam em chegar e querer migrar tudo logo de uma vez, e aí gastavam muito tempo e dinheiro, e no final, quando eles viam o que tinha acontecido, eles perguntaram, tá, mas o que eu ganhei nisso?
So people say, I knew the old system. I was comfortable with the old system. And even though I understand the benefits of using free and open source software, it's no faster. Why did you make me do it?
E então as pessoas chegaram e tinham um sistema velho que entendiam, conheciam, estavam confortáveis com eles, aí migraram tudo para software livre de código aberto e não era nada mais rápido, não tinha nenhuma diferença. Aí eles perguntavam, tá, eu até entendo a importância e o conceito do software livre, mas afinal, qual foi a vantagem que eu tirei disso?
But if it's a new course or something you're doing that's new, why not try and do that using only free software? Because nobody knows how it's supposed to work.
Mas se é um novo curso ou uma nova coisa que se está montando, por que não começar a usar free software desde o começo? Porque afinal é uma coisa nova que ninguém teve uma experiência anterior com aquilo.
Likewise, I also talked about having a plan. Where are you today and where do you want to go?
Da mesma forma, eu sempre falo para as pessoas que elas devem ter um plano. Onde é que você está hoje e para onde você vai?
Now, if these other universities already have a curriculum that can match up with yours, they may also have course materials ready that you could use.
E se uma outra universidade já criou algum currículo que seja parecido com esse que tu estás criando, tu pode chegar e aproveitar esse material que já está pronto para o que tu estás fazendo.
So what would be interesting is if a lot of these universities came together, both ones that are using free software and ones that aren't.
Então seria interessante que essas universidades se reunissem, tanto as que estão usando software livre quanto as que não estão usando.
And the ones that are using free software say, oh, here I teach this course that you also teach, but here's all of my course materials that you could use to teach your students.
Então, uma universidade, por exemplo, que tivesse o mesmo curso utilizando software livre, poderia falar para outra universidade, olha, esse curso aqui que tu estás ensinando, eu também estou ensinando, mas está aqui todo o material que eu utilizo baseado em software livre, então está aqui esse material para ti.
You also have to consider the students that are coming from high schools up to your university.
Você também tem que considerar os estudantes que estão vindo do ensino médio para a tua universidade.
Typically, these high schools have also been using closed source products. So you have to get the students in those high schools using open source so that they're not hit with a shock when they come up to university.
Então, o que acontece é que muitas vezes os estudantes que vêm das universidades do ensino médio, eles já estão usando software de código proprietário, software fechado. Aí, quando eles vão para a universidade, eles encontram softwares de código aberto e tem que se evitar esse tipo de choque também.
Part of the problem are what I call urban legends that have been going around for a long time.
Uma parte do problema é o que eu chamo das lendas urbanas, que estão aí já por um bom tempo.
People say, I need to teach these closed source products because that's what people use on the real life, on the outside.
As universidades dizem que eu preciso ensinar esse tipo de software, que é um software proprietário, porque é isso que as empresas estão usando no mundo real lá fora.
So the professors say, I need to teach Microsoft Office because that's what the people are going to be using when they graduate.
O professor então fala, eu preciso ensinar o Microsoft Office porque é isso que eles vão utilizar quando eles se graduarem.
And the problem I have with that argument is you're telling me that people that you're training to be brain surgeons, you're training to be engineers.
E o problema que eu tenho com isso é que as pessoas que vocês estão treinando para ser cirurgiões cerebrais e engenheiros,
that these people are smart enough to do those things, but they're too stupid to learn Microsoft Office in a single day.
que essas pessoas são inteligentes o suficiente para fazer essas coisas, mas elas são estúpidas a pontos por não conseguirem aprender a usar o Microsoft Office em apenas um dia.
I mean, you can't have it both ways. You can't say that my students are intelligent enough to do brain surgery and build bridges, but too stupid to be able to use Microsoft Office.
Tu não pode ter as duas coisas ao mesmo tempo. É impossível dizer, essas pessoas que eu estou formando são inteligentes o suficiente para fazer uma cirurgia no cérebro de uma pessoa ou para construir pontes, mas são estúpidas para aprender em um dia o Microsoft Office.
And this also goes against my philosophy of not teaching a product.
Isso também vai de encontro à minha filosofia de que não se deve ensinar um produto.
Instead, you should be teaching a concept.
No lugar disso, deveria ser ensinado um conceito.
Do not teach Oracle database.
Não ensine a base de dados Oracle.
Instead, teach how to use a relational or object-oriented database with Oracle as one example.
Ao invés disso, mostre como usar uma base de dados relacional, uma base de dados orientada a objeto, e o Oracle pode ser um dos exemplos.
But you should also use PostgreSQL as an example and MySQL as an example.
Mas também deveria ser usado o PostgreSQL como um exemplo e o MySQL como outro exemplo.
And that way, the students, when they graduate, can pick the best solution for their particular project.
Então, os estudantes, quando se graduarem, podem pegar o melhor produto para um projeto em particular.
Don't teach Cisco networking.
Não ensine a rede com Cisco.
Instead, teach networking with Cisco as an example.
Em vez disso, ensine redes usando Cisco como um exemplo.
And I could go on and on with more examples of this.
E eu posso seguir e seguir com mais exemplos sobre isso. Now I'll ask the question in Portuguese and I'll translate it into English. Indo na mesma linha, porém, tudo o que o Maddog falou é fato, quer dizer, as universidades deveriam fazer isso, deveria existir mais colaboração, especialmente quando a gente fala de universidades públicas, mas, na verdade, faria sentido para qualquer instituição de ensino, especialmente pública. E por que isso, então, não acontece? The question is, the examples that you gave, they are great, and they are really simple. It seems those are the things that public institutions should be doing, and actually not only public institutions. And why aren't they doing already?
Part of it is because of the urban legend thing.
Parte disso é por causa da lenda urbana.
The professors think like this because certain companies want them to think like this.
E os professores pensam dessa forma porque certas empresas querem que eles pensem dessa forma.
And the second thing is that professors, like everybody else, are busy.
E, assim como várias pessoas, os professores também são bastante ocupados.
They've already been teaching these courses a certain way, and they tend to teach those courses the same way.
Eles já estão ensinando esses cursos de uma certa maneira e eles tendem a continuar ensinando esses cursos da mesma maneira.
Now, obviously, we have had universities that have switched, that they do teach using free and open source software.
Mas é claro que nós tivemos universidades que já mudaram, que realmente ensinam utilizando software livre de código aberto.
And usually that's because of one or two professors in computer science make the idea of switching, and they drag the other professors along with them.
Isso tipicamente acontece porque tem um ou dois professores, normalmente da área da ciência da computação, que tomam essa iniciativa e acabam arrastando todos os demais professores nessa mesma direção.
So, I don't know what else to say other than industry and students and parents should go to universities and say, we think this is the way to go.
Eu não tenho mais nada a dizer, a não ser que eu acho que os estudantes, os seus pais, os professores deveriam ir para as universidades e dizerem, olha, eu acho que isso poderia ser feito dessa maneira.
I hope I answered that question.
You did. Thank you very much. Maddog, we are only 4 minutes to end your presentation, and I know that you are quite busy, so if you want to say your final words, please do so, and we will close your presentation. Eu falei para o Maddog, eu sei que ele tem uma missão agora, uma reunião para ir, que é a reunião do conselho do LPI, que já está marcada há muitos meses, e ele tem que sair daqui em ponto às 6 horas. Então, só pedir se ele queria falar umas últimas palavras.
We have unfortunately been in the middle of the coronavirus this year.
Infelizmente, nós estamos no meio da pandemia do coronavírus esse ano.
I'm very sorry not to be down there physically to hug you all and to talk with you myself.
Eu sinto muito por não poder estar aí, estar abraçando vocês, estar falando pessoalmente com todos vocês.
But the vaccines are coming.
Mas as vacinas estão vindo.
And you have to take care of yourselves so that you are still there, your parents are still there, your grandparents are still there when the vaccines arrive.
E vocês têm que se cuidar muito bem, porque vocês precisam estar aí, seus pais precisam estar aí, seus avós precisam estar aí quando a vacina chegar.
I know it is painful not to do the things that you want to do, but it's only for a couple more months.
Eu sei que é muito ruim não poder fazer as coisas que vocês estão acostumados a fazer, mas é só por mais alguns meses.
So wear your mask, do your social distancing, wash your hands, and God bless you.
Então, use sua máscara, mantenha o distanciamento social, lave suas mãos e Deus abençoe a todos.
And I will see you at Latinoware next year.
E eu vejo todos vocês no Latinoware no próximo ano. Thank you very much, Maddog.
Thank you very much for helping. Goodbye.
Goodbye.